All right, let's jump right into this explainer and tackle complete lesson 2.4. Today, we're exploring an absolutely magnificent non-stop engine that has been running our planet since its earliest days. We're diving deep into the continuous 4 billion-year-old machine known as the water cycle. It's an absolutely crucial process for all living things, and understanding it is going to completely shift how you view every single drop of water around you.
Get this mind-blowing fact right off the bat. Our human bodies are made up of at least 60% water, right? But here's where it gets truly wild. Because water on Earth is constantly moving and being reused, the exact same water we drink today has been getting recycled by Earth for over 4 billion years. No way, right? You are quite literally hydrating with the very same water that the ancient Greeks and Romans used to quench their thirst. It's this unbreakable chain stretching across the entire history of the planet.
Okay, so here's our agenda for today. We'll start with Earth's ancient recycling system, then move to moving up with evaporation and transpiration, cooling down as condensation forms clouds, falling down through precipitation types, and finally wrap up with ground and surface water flow.
Let's kick things off with Section 1, Earth's ancient recycling system.
Think of it like a giant planetary puzzle. This is the complete, closed-loop system in action. The crazy thing is, water is never actually lost. Instead, it's just constantly in motion in this massive planetary recycling effort. So whether it's chilling in the oceans, flowing through groundwater, or floating high up in the clouds above the mountains, it's all part of one single interconnected web.
Moving right along to Section 2, moving up, evaporation and transpiration.
So, the whole shebang starts with evaporation. As the sun heats the Earth, the water in our rivers, lakes, and oceans warms right up. When this happens, some of those liquid water particles get totally energized and completely break free from their bonds. They transform into water vapor, which is an invisible gas, and basically escape up into the atmosphere. Honestly, the hotter the day, the faster this great escape happens.
Now here's a detail a lot of people actually miss. Open bodies of water aren't the only upward path. Water also evaporates straight out of breathing plants. You can think of it kind of like plant sweat. If precipitation falls on vegetation, it evaporates directly from the leaves back into the air in a process scientists call transpiration. We're talking about whole forests quietly pumping massive amounts of invisible water vapor into the sky every single day.
Okay, Section 3, cooling down, condensation forms clouds.
Right, so way up high in the atmosphere, those fast-moving water vapor particles hit a serious temperature drop. As they cool down, they lose energy and, well, they just can't move as fast anymore. They slow down, huddle together, and change back into tiny liquid water droplets. When millions of these droplets cluster up, boom, you get the clouds we see floating around the globe. This absolutely crucial phase is known as condensation.
And while clouds are obviously the most massive example of this, you can actually see this atmospheric phenomenon happening right down here on the ground. You know that thick fog you see over a cold lake early in the morning? Yep, that is invisible water vapor losing energy in the chilly air and condensing right back into visible, floating liquid droplets. It's the exact same science, just happening right in front of us.
Next up, Section 4, falling down, precipitation types. As air currents push these clouds all over the world, more and more water vapor condenses. The tiny water droplets in the clouds start gathering together and merging, and eventually, they just get way too heavy for the air to hold them up anymore. Once they reach that tipping point, gravity violently pulls them right back down to Earth.
We call this precipitation, but it doesn't always look the same, right? Depending on exactly how cold those water droplets get before they drop out of the sky, they'll hit the Earth in a few different forms. If they just get heavy, they fall as rain. But if the atmospheric temperature really drops, they might freeze and come down as snow, hail, or sleet.
And finally, Section 5, ground and surface water flow.
Okay, so once that precipitation hits the ground, a huge chunk of it doesn't just hang out on the surface. Instead, it soaks right through the dirt and rocks. Sure, some of it stays in the shallow soil layer and moves towards streams, but a ton of it soaks way, way deeper underground to refill these massive hidden stores known as groundwater. Let me tell you, this underground network is just as vital as the rivers we can actually see.
But in colder regions, the water might literally hit the pause button on its journey. Instead of flowing or soaking in right away, the precipitation stacks up on the land as solid snow, ice, or even massive glaciers. It can stay locked in this solid state, sometimes for thousands of years, until the temperatures finally rise enough to melt it into liquid water, which then finally soaks into the ground or flows into rivers.
On the flip side, the water might not soak in at all. If the ground is totally saturated or really hard, water flows rapidly and directly over the land. We call this surface runoff. And while it does eventually feed our rivers and oceans, a massive amount of rapid runoff can physically carry topsoil right off the land. This dumps all that dirt into rivers, causing them to get dangerously silted up and blocked.
But here is the really cool takeaway. No matter the path, whether that single drop of water trickled into a plant root to be transpired, flowed rapidly down a river as surface runoff, or took centuries to finally melt from a frozen glacier, it inevitably meets the sun's heat again. And when it does, evaporation begins anew, endlessly restarting this unbreakable 4-billion-year loop.
Knowing that every single drop of water around you and even inside you is a working part of this ancient global recycling machine really changes your perspective, doesn't it? So I want to leave you with this provocative thought to ponder today. As you think about those interconnected rivers, the deep ancient groundwater, and the falling rain, where exactly does your drinking water come from?